Hey guys, we have another proof problem. So in this case, we are going to prove two lines are perpendicular if the slopes product is -1 or the other way around. Okay, so meaning that like if okay, let's actually prove and see at the end. So this line, like we have VP and we have PZ. I mean PZ. Like this is PZ and then this is VP. So those are perpendicular, right? That's given. The meaning that they are intersecting with a 90 degrees at that intersection point. So, and then we are given some sort of triangle, which is called slope triangle in some resources. So, so we are going to find the slope of the line VP. So this is line VP. So just as a reminder, so there are a couple of ways to find the slope. The slope is just the steepness of a line. So one of the ways that we use like difference of the y's divided by difference of the x's, right? But this is something we can use if you know the coordinates, but if you don't, so it might not be that useful. Another way to say the difference of the y's, that is called rise basically. And then difference of the x's is called run. So if you are using rise over run approach to find a slope, you have to be careful because you can just see the rise over run as a distance and make sure you determine the sign of the slope based on how the line actually given. Okay, so meaning that if the line goes upward like this, that will be positive slope. If the line goes downward, should it be negative? So find the slope of VP. So this is the this is V, this is P. If you want to find the slope of this line, so you need to use this triangle, and then this is gonna be your rise. Okay, this is gonna be your rise, and then this is gonna be a run. So that means if you look at the choices, the slope of this guy would be, the rise is gonna be WV, right? So VW, so this is one, and then this is another one. But as I said, if you are using rise over run, you have to be careful. So the sign should be determined by the given line. Since this goes upwards, so it has to be positive, so we cannot choose these guys. So I have to choose VW, which is gonna be my rise, and then WP is gonna be my run, okay? And that's the slope of the first one. And the second one, so the slope of PZ, so I should use a similar idea. So let's do that. Give me a second. Okay, so yeah, let's continue. So the second one, the slope of this line, I'm gonna just use this still rise over run. So to do so, okay, so I will just let me change the color. Okay, so the second one is the slope of this line PZ. I will just take the rise as this guy. This is rise, and this is gonna be run. So the slope of that would be, the rise is QZ. So if you look at choices, that's QZ, and then this is QZ. But the line goes downward, so you should have a negative in front. So which is why I will take this guy, and then the run is PQ, which is right there. So that is my slope. So for these two lines based on the rise over run approach. Okay, so let me clear this. And then as soon as we have the rise over run to use this to get their slope, so we are gonna see, we can show that those two triangles are similar. Based on this, choose the ratio that is equal to this. So to determine this, I have to kind of be careful, I guess, because we just said, you know, the triangles are like having the slopes are this ratio and this ratio, right? So, and then if the slopes are equal, so this side divided by this side is just the slope, and in that case the other one was given. But if you see this ratio and this ratio are gonna be equal if they are gonna be similar, because if they are similar, you know, that's basically meaning of this triangle and this triangle are similar, then they has to be proportional on the corresponding sides, right? So, but how do we know what sides are proportional? So there are a couple ways maybe we can do. One of the things is, you know, I can use something we call angle chasing, meaning that if I call this is alpha and this is beta, alpha plus beta is 90 degrees because this is 90. So these three add up to 90, 180. So these three add up to 90. And since this is a right line, straight line, and the alpha 90 and this part has to be 180. This is already 90, which means this alpha plus this part has to be another 90. So which is why this has to be beta. Otherwise, you cannot get a straight line because alpha and beta was 90 degrees. So this is also 90. And then similarly, in this triangle, this is 90. This angle plus this angle should be 90. It's the only way that will happen if this is alpha. So now you can just write the ratios based on this. So we are told in the problem asking, we are told that those two triangles are similar, right? So we can just say V, because that's what we are given, divided by WP, VW, VW, right? So this is the side opposite to angle beta, the beta is opposite to PQ. Okay, divided by WP is this side, which is opposite to alpha. Alpha is opposite to QZ. Okay, so that is my ratio. And if we look at the given triangle, so we are told the VWP is similar to PQZ. So V and W is the first two letters. So V and W is the first two letters. The first two letters is PQ, which is, as you see, I have it based on my reasoning. And then the denominator is WP, which is the last two letters. So QZ has to be, which is the case. So I use my angle chasing to see what angles are actually correspond to each other without really knowing they are similar. We can actually use this angle chasing to see those are two similar triangles. As soon as we know they are similar, we could just write this ratio, but it says in the part B, it can be shown that this triangle and this triangle are similar, which I just did by angle chasing, okay? And then if that's the case, what is the ratio equal to WP? I mean, VW divided by WP, which is PQ divided by QZ. So PQ divided by QZ is the given one. And using this result, we will choose the correct statement. So we got so far, if they are equal to each other, you know, we got this ratio is the same as this one, right? So VW WP is equal to PQ divided by QZ. So I think that looks like this is the case, but let's check that. So we have the PQ divided by QZ. I think that might be the case. So I will double check with them. Okay, so and then based on that, the slope of VP and slope of PZ, they are not equal to each other. They are just the negative one because they were negative version of each other. So slope of VP was the slope of negative version of that because we got at the first part, it's gonna be negative because the slope goes downward and then this is a positive, that's the slope is given. So the slope of VP and slope of PZ is just a negative version of each other. So we can just say that is the case. And if they are just negative version of each other, then their product is gonna be -1. And then we call that is two slopes are negative reciprocal. So that should be my reason. So let me check this statement just to be safe. Okay. So we had the slope of VP. Okay, so VP is this guy. The slope is rise, which is VW divided by WP, which is this. And PZ is the rise is QZ divided by PQ. I think that was correct. Yeah, I think that looks good. Okay, so let's double check and see if that's the case. Okay, so I think that was correct, and the slope was the PQ to Z, the ratio is equal to each other. And then slope product is -1. Actually, I should choose this one because when you multiply the slope of this guy and slope of this guy, you got -1. So slope of this is negative version of that. I think the product is -1. Yeah, I just did that. So yeah, whenever you have the first relation VW divided by VP, this is the slope of the first line. This is the slope of the second line. If you multiply this slope by this slope, okay, and you actually get -1. So that is why we have to choose this product to be -1. So anyway, so I'll see you next time.